Okay, so what I want to do first before we get into these notes is I want to recap something with which you're pretty familiar. So you don't need to write this stuff down, just kind of watch what I draw and answer my questions. If I give you a function and I ask you to graph y equals x squared, what will this look like? It's a parabola, right? Okay, so that's the parent function for a parabola. If I then graph a parabola with the equation 3 times x plus 4 squared minus 7. What do each of these numbers then do to that parent function? So what does 3 do? Yeah, so it's going to stretch it vertically, right? So it's going to grow a lot quicker in the y direction as you count in the x's, okay? What does x plus 4 do? Yeah, it's going to shift it to the left 4. It's opposite of what the sign says it is. And then negative 7 shifts it down 7. If you can answer all of those questions, then you're ready for today. All we're doing are the same transformations, which we've already done the stretching, right? Like this takes care of the amplitude that we've already discussed. But the other stuff, the shifting left, down, and up and right, that's what we're going to talk about today. Okay, so before I even do that too, if you look at, so again, you don't need to draw this. If you look at the sine and the cosine functions, so I'm going to graph the sine function in blue. Sine function would look like this. And I'm going to graph the cosine function in red. Do you notice something about these functions? They start in different places, right? Cosine starts at 0, 1. Sine starts at the origin. But what if I shifted cosine? It would be sine, right? If I moved this point half pi over, I'd land on that point. And then if I shifted this point, I would land on that point for sine. And then this point would land on this point for sine, and this point, et cetera, right? So what does that mean about sine and cosine? Say again? Yeah, at certain parts, if we were to shift the cosine graph and write its equation with a phase shift, we would literally end up with the sine function again. So on your homework, I know some people, like for number 11, were like, how do you know if it's going to be sine or cosine? Typically, if I don't shift the function, then sine will always go through the origin and cosine will always not go through the origin. That's what will always happen if there's not a phase shift. If there is a phase shift, then essentially sine and cosine are equivalent to each other at specific points. Okay, so that's just kind of a recap and a connection using phase shift. Okay, so for phase shift, this is just a fancy word for horizontal translation. So this is, you can go ahead and start writing now. Phase shift is just a horizontal translation. Okay, so here's what it means. If I give you basically like the general equation for sine and cosine. So if y equals a times the sine of k theta plus c, and I'm going to write the same equation but with cosine. And y equals a times the cosine of k theta plus c. And thanks for bearing with the blinky screen. I know it gets annoying, but it'll be easier for me to explain things to you live when we do the graphing stuff here in a few minutes. Okay, so if we have these generic forms of our equations, then phase shift or horizontal shift is equal to negative c. Oh, why won't you let me write the negative? There we go. Negative c over k. Negative c over k. Another way that you can think about it, if you prefer, and it's what we did when we reviewed that parabola shifting. Another way of thinking about it is simply to set parentheses equal to 0 and solve. This will also be a different way that'll tell you how far it is shifting to the left or to the right. Okay, so we're going to do some algebraic examples. All I want you to do is find the phase shift of each trig function. So for example A, I've got cosine of theta plus 5 pi over 6. So using our logic that we know from translations of other parent functions, when we have theta plus 5 pi over 6, we know that it is opposite. So we're actually going to shift to the left 5 pi over 6. Now, if I did negative c over k for this example, what is k? It's 1, right? So me doing negative c over k dividing by 1 does not change anything. So if k is 1, then you basically just switch the sign and you have your answer. Same thing for b. Sine of theta minus 3 pi over 4. K is 1, so we can just use our logic to what value of theta makes the 0. And this is going to be shifting to the right 3 pi over 4. Okay, part C and D are a little bit different because K is not equal to 1, so we have a little bit more algebra to do. So I'm going to do each one of them with a different option, and you can choose whichever option you prefer. For C, I'm going to do option 1, which is to set the parentheses equal to 0 and solve. Okay, so I'm going to set theta over 2 plus 3 pi over 4 equal to 0, and I want to solve for theta. So if we subtract 3 pi over 4 on both sides, then I've got theta over 2 equals negative 3 pi over 4. And then since I have a proportion, I can go ahead and cross multiply. Right? So if I do that, then theta times 4 is 4 theta. And then 2 times negative 3 pi is negative 6 pi. And then if I divide both sides by 4, then I get theta is negative 6 pi over 4, which reduces to, anyone? Okay, awesome. That negative indicates that we are moving to the left 3 pi over 2. And we knew it was going to be to the left because our original set of parentheses was plus, and it's always going to be opposite. Now, the word left takes care of the negative sign. So you wouldn't put left negative 3 pi over 2 because that's redundant. Okay, so the words left and right take care of, are you talking about a positive theta or a negative theta? Now for part D, I'm going to do option 2, which is if we just do negative c over k. So this is going to be option 2, negative c over k. So what is c? Okay, so negative c will be negative 7 pi over 6 over k, which is, okay, when we divide fractions, it is the same thing as multiplying by the reciprocal. So we can rewrite this instead of negative 7 pi over 6. That'll be positive 7 pi over 6. And then instead of dividing by 8, we can multiply by the reciprocal of 8, which is 1/8. And then we multiply fractions straight across. So that's going to be 7 pi over 48. Since it's positive, that means we're going to have right 7 pi over 48, which we knew it was going to be right because the initial sign in our parentheses was negative. Does anyone have any questions about how to algebraically find the phase shift of a trig function? Okay. Phase shift is the difficult one of the two, if you could even say that. Vertical shift is just extremely clear. I mean, it is exactly what it sounds like. It's taking our graphs and shifting it up and down. So we're going to say if y equals, we're going to just add 1 part to the equation. So a times the sine of k theta plus c plus h is the new part of the function. And we're going to write the same equation with cosine. So and y equals a times the cosine of k theta plus c plus h. Then vertical shift and midline are y equals h. So I've used the term midline throughout this chapter, and so far the midline has just been the x-axis, right? Because we've been graphing our sine and cosine functions, not moving them at all. So the midline has remained the x-axis. If we shift our graph upward or downward, then the midline shifts with it. So it's just literally the line in the middle of your curve. Algebraically, finding vertical shift is extremely easy. It's just the constant h that's hanging out by itself. So like, for example, E, what's your midline, or what's your vertical shift? Yeah, +1 just means up 1. And then for F, addition is commutative, so it's okay if this -4 is out in front. That's going to be down 4. Okay, questions so far? Okay, so I'm going to do 2 examples with you. You have your homework sheet as well, which you're going to notice has 8. So if we finish this with time left in class, you'll start working on your homework graphs. And then if you don't get it all done tonight, you have all of tomorrow's class to work on them. Okay, so we are going to recap how to use our calculator to help us graph these functions. First and foremost, as I mentioned to Asher earlier, you need to make sure that your calculator is in radian mode in order for your graphs to pop up. Okay, radian mode. So let's find all the algebra stuff before we do the actual graph. So the amplitude, how do you find the amplitude? Well, is the first number 1 or first number 3? Okay, so give me what variable based on our equation. Yeah, okay, and better yet, how about the absolute value of A, right? Because if A is negative, that amplitude distance is always positive. So in this case, the absolute value of 3 is 3. How do you find the period of a function? Okay, where is K? Okay, so it's the coefficient of theta. So in this case, K is equal to 2, which implies that our period is 2 pi over 2, which reduces to just pi. So what is the typical period of sine? So now this function is going to make 1 cycle in half the amount of time. It's going to make 1 full cycle in pi instead of 2 pi. We find phase shift. Since y'all are pretty good with setting parentheses equal to 0 and solving, I'm going to do phase shifts as negative c over k. If you prefer to do the other way, that's fine. Negative c over k. What is c? Yeah, 0. It ain't there, right? There's nothing tied onto your theta or added or subtracted on from theta in parentheses. Therefore, you could just put none. There is no phase shift. And then vertical shift is found by the constant hanging out by itself, which is h, which in this case is 1. And make sure you put direction. Since it's positive, it'll be up 1. Okay, what I want to do with that vertical shift, remember this is also dealing with a midline. So if that midline is at y is equal to 1, what I want you to do is actually graph a line, a horizontal line at that point. So now this is where our curve will be centered around, so to speak. So remember how yesterday or a couple days ago, when we were talking about graphing, how I told you I only care about the zeros, the maxes, and the mins? When I say zeros, I am only talking about, typically, so far it has been literal zeros, like where it crosses the x-axis. But now when I say zeros, because we have this idea of a shifting, I care about the intersection of the midline. That's what I mean by zeros. I don't care where it crosses the x-axis. In fact, sometimes your graph will never cross the x-axis now because we can shift it all the way away. Okay, so when I say zeros, I'm really only talking about the intersection of the midline, and then your maxes and your mins like normal. Okay, so let's do this. If my midline's at 1 and my amplitude is 3, right, where will my maxes and mins occur? Like, where will those points be? What horizontal lines? Right, so you count 3 in each direction. So let's go ahead and put a dotted line there to help us know where those points should be. So an amplitude of 3 this way and 3 this way. That's where our maxes and mins will be when we graph them. Okay, so let's recap how to use the calculator. In your calculator, the first thing we want to change is our window. Your window. So remember the goal is to try to get our calculator screen to look like the graph that we're trying to graph on so that it matches exactly. What's the x min value that we see on our graph grid that I gave you here? Negative pi over 4. The max value will be 2 pi, and your grid counts by, that's the scale. What is the scale of this? 1/4 pi, right? Or pi over 4. Now, Francisco, I think you heard me, or I heard you say the other one. So what is your y min and max? That's it. So y min is -6, y max is +6. Y scale is equal to 1. So for this, guys, right now, you know, I'm not requiring that you write what your window is. Right now, I'm just writing it so that you're aware of how you're putting stuff in the calculator. I'm not going to say I'm never going to ask you what you put as your window, because that would be a good indication for me and Mr. Ware to know if you're knowing how to use the calculator correctly. What is the other thing we need to change? The table sets. So that's going to be on second window. So if you hit second window, the table starts, you can just put that at 0, right? Your origin. But when it says delta table, what do we want that to match? The scale, right? So you want your table to match the scale. Trent, you doing okay? All right. So now if you change your table set, then you can go take a look at your graph to know what it should look like. to have an idea of where things are going to be. And then after that, you can actually look at your table. So looking, not the table set, but look at the regular table. So hit second graph. And then we can figure out where our coordinates should be and actually graph our curve. So at 0, what is my y value? 1, and it should be, right? Because we knew that that's where the midline was going to be. Then remember, because you put things in as pi's, everything's going to be crazy decimals. So pi over 4 doesn't look like pi over 4. What is that y value at pi over 4, though? It's at 4. At pi over 2, we're back down to 1. At 3 pi over 4, which is like 2.3562, we're down to -2. At pi, we're back up to 2, or sorry, up to 1. At 5 pi over 4, which is 3.927, we're up to 4. At 3 pi over 2, we're back down to 1. At 7 pi over 4, we're back down to -2, and at 2 pi, we're back up to 1. Are these the same points y'all got? Okay, now yesterday, after we graphed the lovely looking points, we looked at our graph and we noticed that it wouldn't actually be the same. We were missing a lot of points. And guys, that's gonna happen. In fact, our next example is gonna be just completely off the grid in terms of lovely looking numbers. So when that happens, you just gotta estimate the rest, okay? Now, if you look at your picture, does it look like these are enough points to show where the curve should be? Yeah. So then you can just go ahead and make a lovely curve between these. I apologize for how messy mine is. It's hard to curve without putting my palm on the screen, which I can't do. But make sure you put a curve to them and not just to straight lines to each peak and valley. Any questions so far? Yes. Great question. And I want to talk more specifically about example G, how we're going to enter that in the calculator too. Okay, for G, let's go ahead and do the algebra part first. And then we'll graph it. Okay, amplitudes found by doing the absolute value of A. What is A? The absolute value of 2 is 2. So our amplitude is, or the distance from the midline is 2. Period is found by 2 pi over K. Well, what is K? 4, right? The number in front of theta. So that's going to mean that we're going to have 2 pi over 4, which reduces to pi over 2. Phase shift is either done by setting your parentheses of your sine function equal to 0 and solving, or negative c over k. So what is c? Yes, make sure you include that negative. So it's going to be negative c will be negative 5 pi over 6 divided by k. You guys already told me k was 4. But when we divide this, you remember you want to multiply by the reciprocal. So negative switches to positive 5 pi over 6. Instead of dividing by 4, we're going to multiply by the reciprocal of 1/4. And then we will multiply our fractions straight across. So it's going to be 5 pi over 24. Since it's positive, this means we're going to go to the right. And correct. And again, using your logic from what you know about other parent functions, if you look at your parentheses from the get-go, Since it's 4 theta minus 5 pi over 6, we know it's actually shifting the opposite direction that the original equation shows. So if that's a negative, we know it's going to go to the right. Okay, vertical shift is just h, the variable hanging out by itself. Since it's a plus 3, this is going to be up 3. Okay, so next thing to do is go to your, notice, first of all, the window and your table sets, your graphs look exactly the same. So we don't need to go edit our window or our table sets. We do, however, need to go into y equals, clear out your old function, and type in this new function for g. When you type it in, you need to be extremely careful that you type it in correctly. Okay, so you want to make sure your calculator screen is going to be 2 sine. When you put sine, it automatically opens up some parentheses, right? So then you're going to put 4 instead of theta. Remember, we're using x. Minus, when you input 5 pi over 6, you need to open a set of parentheses and put 5 pi over 6, put that fraction all in its own set of parentheses to tell your calculator it is one fraction. Now, tell me this, those of y'all using yellow calculators, does it look like my writing does here, or does y'all's calculator, when you hit divide and make a fraction, stack it over each other like this? Okay, so it doesn't stack it automatically. Okay, so if it looks how I first wrote it, you got to make sure that you use those parentheses to show that that fraction is all together. Okay, and then additionally, you need to make sure you close the next set, or you close parentheses, right? Because all of this is in sine before you put plus 3. Because if you don't close the sine parentheses, it's going to think that plus 3 goes inside of those sine values as well. Yes, sir. No. When you write it handwritten, you typically use brackets, but your calculator doesn't, I mean, it has bracket options, but double and triple sets of parentheses get the job done as well. But that's a good point Mr. Ware just brought up. Visually, when you write things, it's easier to read math if you know that your brackets, kind of the further you go out, the more you change your parentheses into brackets. It's just visually easier to see what should be grouped together. Okay, now, before we graph it, I want to graph my midline. Where is the midline of this function? Yes, right? It deals with your vertical shift. So the midline is going to be at y equals 3. So I want you to graph a solid line at that y value. And remember, those are where our quote-unquote new zeros are going to be. So your curve is going to be centered around this horizontal line now. Okay, if the midline's at 3, if the amplitude is at 2, where will our maxes and mins be? 5 and 1. 2 and 2. So graph a dotted line at 5 and at 1. So remember, when you graph, I don't really care about any other points other than points that are going to be on these 3 lines. So here's what's weird. What is your phase shift? 5 pi over 24. We're taking the sine function and we're shifting it 5/24 pi to the right. The increments on our graph, on our grid, are not counting by 24ths. What are they counting by? So the shift is so minute that the points are not going to, I'm going to say, snap to the grid of one shift over. Okay, so if you actually look at your table, go look at your table. Do you see how the only coordinates that they provide us with for the y values are 2 and 4 and 2 and 4? Yes, y'all see that? Those are just random points in between your curves. So when this happens, you know just by doing the algebra, not putting anything in the calculator, that your minimum values are going to hit at 1, your maximum values are going to hit at 5, and your zero values are going to hit at 3. So this entire graph is going to be estimated. Okay, if you wanted to graph those points in the middle at 2 and 4, you can, but they're just somewhere in the middle of your curve. So it's just going to kind of make your graph look messy. So what I want to do is look at the picture of your graph now. And I just want to go through and estimate where all of the minimum values are. So the first minimum value, it looks about almost a third-ish between the first and the second x value. Does that look right to you? Like somewhere about here? And you know all your mins are going to be on a 1. So let's estimate where all the minimum values are. The next one looks like it's a little bit after the second tick mark. So that's going to be a little bit after pi over 2. And if you look on your calculator, where do all of the minimums occur? How far away from each other? Well, look, how far are these two that I just graphed from each other? Well, not 2 pi. Pi over 2 away, right? Or if we're talking just numbers on the grid, 2 grid marks away. So again, you could look at your calculator and count the tick marks there, or just say, notice the pattern. Oh, I noticed they're all pi over 2 away, so I can graph my other minimum values pi over 2 away from the ones that I've already graphed until I reach the end of my graph. So again, 2 more away, or pi over 2 to the right, should be about here. 2 more to the right should be about here. And then 2 more to the right will be a little bit off the grid there. So those are my min values. Yes. Yes. Correct. Sure, and that's exactly what it should be. So exactly. So in other words, that's just if we skip 2 over, it's going to be 1 over from each of these dots. So if you, just like he said, if you split the difference between your dots, you will get the maximum values. And it's all estimation. If you're OCD and you're kind of lost right now, we are just estimating where these should be. Now, the zeros, quote unquote zeros, right, where it crosses the midline, those are going to be a little bit more difficult to figure out where they should be, because we don't have any point of reference on our graph unless we also graph the line y equals 3, which you could do, and then estimate where it crosses. Right? But I'm okay when the midline is not 0, as long as you graph your maxes and your mins. If you haven't shifted things and it's all estimation and your table doesn't help you, I'm okay with you using these maxes and mins to estimate your curves. So it should look something like this. So this one, because it had a really weird phase shift by a factor of 24, we had to do so much estimation because the table, counting by increments of 4, didn't really help us split it up enough. Okay? Yes, yes. Remember, make them curved, don't use straight lines. And guys, this is about as tough as it gets. For your homework, those 8 problems, I tried to make those factors of 4, factors of 2, to where when you graph them, it's going to be a lot easier for you to do the shifts just by using your table. Okay, so homework is the other page. I recommend you going through, even though it's not due till Friday, I recommend you going through maybe tonight, doing all the algebra for every problem. That way tomorrow in class, you can focus on the graphing, especially those of you that don't have a graphing calculator. You'll definitely need to make sure that you are speedy in class tomorrow to get it all done.